Annotation, right?
Yeah, so more like annotating where I'm going to show you guys how to annotate and prepare your data set so you can use it for training. All right. So if you go to Roboflow data sets annotation like this. Okay, I think this is the correct one. So we need to like get our data sets and I'm going to download a data set of we'll come back to that traffic something. Let me find something simple. Let me find data set of brain tumor. No, let's say cancer. No, brain tumor image show data set. These guys already have it on Roboflow. Let me get the one from Cargo. How many MB is it? Good. I like this one. Okay, so we need to annotate this data set for. Hope you guys are seeing my screen, right? And you're hearing me well.
Yes.
All right. So there are four brain tumors here. 300 files. These are four types of brain tumor. But we're going to use only one. I'll pick one and I'm not writing me brain tumor for here, but okay, see brain tumor here. This place here, there's tumor here. There's tumor here. There's tumor, there's tumor. And this is only a little image. We need to annotate the data set so it can identify where there's a tumor, right? So I come here, these are all images. There's a lot though. I'll annotate like 5 of them or 20 of them and show it to you guys. So you come to Roboflow, then you get started on Roboflow. So the reason I'm getting pens, I wanted to show you guys why do we annotate data sets in computer vision. So normally in AI, normally in I told you guys about we get data set like this. We have a data set called D. Then with data set, we want to use it to train a neural networks model of let's say like two neurons like this. Want to train this neural network model. Well, one of the things we should do should be that we label the data set. Let's say the data set was called Daniel. This one was called Ben. We label the data set and then you pass it to this neural networks model, to these neural networks, right? Once you pass it, use it to learn, and then from learning, it gives you the result Y, right? So now we want to train this neural networks model to be able to detect this. But now in this case, we want to build an AI model that if given an image of a brain tumor, say this is a brain MRI scan, you should be able to know that this is a brain tumor inside it. So one of the things we do in computer vision is that instead of passing the image, then passing labels, because if we pass like a full image like this, if we pass like a full image like this now, for example, it will be hard to identify where there's a brain tumor here. To just know that there's a brain, to know that there's a tumor. So we wanted to know where exactly the tumor is. And that's where what is called landmark or boundary boxes comes in. So boundary boxes are like just a box that is around where the main detection is. So we tell the AI, we want the AI to predict that in this image, the brain tumor is in this particular location. So it's more like in a vector database or in a graph, in a land graph. This is my X and this is my Y. All right. We want it. So this is, let's assume this is the full image. This is X, this is Y. We want it to know that the image is at this particular, the brain tumor is at this particular location. We need to the model is going to do something called like landmark detection, or give you like draw some bounding boxes around where the thing is. So we need to tell it that okay, the image is at this particular location. In mathematics, how do you find something in a location if you want to find something like this? So this is going to be your X. Let's say this was 1 to 5 on the graph. The scale of the graph was 1 to 5. So the location of this image is in location what? This is 1. Let's say this is 2. This is 3. Is in location what? 1, 2, 3, 4. Is in location 3. X equals 3. Location 3 of what? Y equals what? 1, 2, 3, 4. Of Y equals 4. And this is on a 2D graph, two-dimensional graph. This on a graph where like we just want to like just get only this one point. But now this particular location, we want to get the full point, the full place where it is located. We want to like get the full location where it is. So now we need to get two vectors, like for the X, two numbers for the X. So for the X, we are going to get something like the first place where the image is starting from. So right now the image is starting from location 1 to 2.5. 2.5. The X1 is going to be equal to 2.5, comma, X2 is going to be location what? This is 4. So let's say the image was big, like location 2.4. Sorry, location 4. That's for X. And then the Y is going to be my X1. This is going to be my X2, right? Then my Y1 is going to be where? This place. Y1 is equal to 1, 1, 2, 3. Y1 is equal to 3 of location what? This 3 location 4.5. So with this, our if we pick this coordinate now and pass it on a simple Python script and say draw something in this particular location of pixel in this image, it will be able to draw it. So that's what you see here. We see something like landmark detection. When you look at images, you see something like this. You see, or you do like objects. You see. So this image, for example, now this is this is this image, for example, this is X1, X2, Y1, Y2. With this, if we pick this thing and plot it, we can be able to draw this rectangle and join it together. Do you guys understand what I mean? This is how we are able to draw a rectangle on an object detected. We use like landmark detection to detect the landmark and then draw like a bounding box around it. Do you guys understand what I'm saying?
I don't
If
think
Yes.
I
you
get it.
hmm. No, do you understand?
Yes.
So, for example, Janet, that image, that video you showed to me, you see, you were able to draw the car, Abby.
Yes.
So
Yes.
how this model managed to draw this thing is that we need to find the exact location where that car is on the image. Do you
Mm.
understand? So to find the exact
Yes.
location, we need to like draw a bounding box around the image. And in
Okay.
mathematics, to get this particular location, we need to find where it starts from and where it ends. So on the x-axis, the
Okay.
image starts from this particular location. So let's say this is 3. It ends at location 6. This is going to be our x1, this is going to be our x2. On the y-axis, the image
Okay.
starts from here. This is 2, and let's say this is 5. So this is going to be y1, y2. So if we pick this thing and plot it, we'll be able to draw an image, to draw
Okay.
something. You understand what I'm saying?
Yes. Yes.
So I do something like bounding box object detection now. You will see what I'm saying. So if you look at this, you will see exactly the thing I'm telling you. Um if you look at this image, it's going to be our x, right? So this image is looking like this. This image is looking like this, right? So if you come here, this is going to be our x, right? These are x1, these are x2, these are y1, these are y2, all right? And a line of our graph. So now I need a very good example. Correct. So if you look at this is the height, this is the width. So this is my bx, comma by. We are trying to get this exact point here. You feel me? So we pick this thing and then we plot it. Well, let me check if I can find for OpenCV.
You're muted.
Sorry, is anything the problem? I don't know if it's my network. Hello.
Hello.
Maybe his network is acting up or what? I don't know.
Let's wait for him.
Yeah. So, we can hear you.
Yeah, 1 minute. My internet went.
Oh, okay.
Is it okay now?
We can hear you. I don't know if you're sharing your screen.
Okay. Sorry. Mhm. Network disconnected. Oh. Let me continue sharing. So um I wanted to show you guys something about So did you ask for the kids? Yeah, it's calling. Someone is calling. So if you look at this, can you guys see my screen? Can you see
Yes.
my screen?
Yes.
Yes.
Yeah.
So this is now what differentiate between object detection and image classification. You see, they are like two different things entirely. So object detection is when like I give an AI model. What's going on? Why is my this thing putting? Object detection is when I give like an AI model and then bent. And then I tell the model, oh, recognize recognize like this old image to be an apple. So let's say this image want to be like this image is an apple. You see, this is what object detection is. Sorry, image classification. So we are trying to classify an entire image. But object detection on the other hand has to do with like being able to detect the exact location where the image is, you know, detecting the exact location where the thing is, and then identifying it. So if you look at this, you will see that you see this is x1, y1, x2, y2, where x1 and y1 represent the top left. This is the top left, right? This is the top left. This is the x1. This is the x1. This is the first location, and then this is the y1, the top location. Now x2, y2 represent what? Represent the top bottom right, which is this particular location. So we just want to get this four coordinates, four coordinates of this location in this line in this graph. This is going to be my x2, this is going to be my x2, this is going to be my y2. If I get this successfully, I can plot this image. I can plot this image and draw something around it. You feel me? Janet, do you understand? Janet,
Yes.
and
Yes, I
then
get it.
once I can plot these four dots, I can join them together as a line. So that's how we managed to do that's how we managed to do object detection. That's how we managed to do object detection. So now if we want to train an AI model to classify and to detect an object, one of the best thing we do is to annotate the data set. Data set annotation means we take an image, right? So instead of like going to, because we want it to be able to detect images. So let's say we have an image of like soup. We want it to detect like the full stock, maybe fish, meat, periwinkle in that particular soup. Now you see that's an entire image. So you need to be able to identify the exact location where there are food stocks. All right. So we need to
Hmm.
tell the AI model that Jenny is saying, we need to tell the AI model that in this particular image, this is where the full stock is, and that's where annotation comes in. So when we want to train the model, we first of all arrange our data set by annotating. So we annotate this particular location like this. One. We annotate this location, this second location. Let's say there were like four objects in the image. We annotate it. Then after annotating it, we classify. So we are annotate like this one is one, this is two, this is three, this is four. One meaning periwinkle, this one meaning fish, this one meaning goat, this one meaning cow. or beef inside. So now with this, when we are training the AI model will use these labels that we annotated it for, and they use it to train the model. Now we want to test the AI model. The AI would be able to tell us that, oh, based on this particular thing you did, you annotated, this image right here is an image of periwinkle. This image of a whatever, this image of whatever. So data annotation is one of the most important steps needed. So with this, we can arrange our data sets and make our AI model to know that this is this particular image in this location. So let me see if I can open any image. For example, in this image of this guy, for example, if I want to train an AI model to detect a human being, if I'm annotating, I'll annotate this location like this. This is a location where there's a human being here, right here. So when I annotate it, when I pass this image to the AI model, so let's say this is the AI model right here. When I pass this image to the AI model, the AI model will know that the image is trying to train for is on this particular location. It's more like saying I'm trying to crop the image out. So we are trying to crop that particular pixel where there is the right data set we are looking for in, right? And then we pass it to the AI model. Do you understand?
Yes.
All right. So now, so let's say we want to annotate a data set for both for training. We can use this. You can use Roboflow, but I prefer to use Roboflow because we can it can be this one. Roboflow don't they do ads because we can what's it called? We can augment the image. We can like tell it turn it up right before we export it. Turn it left, right, then give it a lot of instruction. And then from there we can generate more images. So there's that's it, like, some things like this sometimes. I want to create a new project. I come here, come to project, want to create a new project. I want to call it Brand Tomo. So project name is Brand Tomo. Annotation group is uh, I'm disturbing. Wahala, everywhere choke. Wahala. I'm in a meeting.
Don't know.
Oh, knock.
They don't knock their door.
Okay.
You're supposed to be this side.
For us, we are supposed to be. For us, we are this side, they are this side. We are not part of us, so they may say we are disturbing them, and then we don't come back again here. Okay?
Is he angry?
Yeah, because he rents here. This is another
I'm in a
place.
meeting.
Yeah, you're in the meeting, but these ones were complaining. That's you.
Maybe we're good. All right, Brand Tomo. Visibility, private, and object detection. Yeah. So are we trying to do an object detection task or like classification, image segmentation task, key point detection, or multimodal? So what we're trying to do is an object detection task, right? So
Sorry, before you move, please can you hear me? So I think
uh
I've been meaning to ask this particular. I think I find it confusing from this like segmentation, the detection thing, because I noticed that YOLO also has something like seg ahead, and somehow it also dictates like image. So I want to ask, what's the difference?
yes, image segmentation and detection, like object detection more like helps you to like just detect the bounding box, but segmentation goes more deep and give you like more details about that thing. So it looks like, you know,
Oh, okay.
image segmentation is like this. So it doesn't just it give you like full detail about the image, you see, everything. Object
Okay.
detection, just drawing a bounding box around something. You feel me? Okay. So start building, use traditional model builder instead. What? So click here, then and we need to import our data set. So I'll just select a folder on my PC. I'll come here, select this folder, and I'll upload. Again, to upload, hope there are no much images, shall. For that data set, we recommend using the Roboflow CLI for more reliable upload process. Yeah, I can upload from this here. Okay, so now these are the images that we're going to be working with. And then we are going to upload. I think, man, this is a lot of images. 1,300. Is anyone that is smaller? Oh, yeah, 132. 133. 194. Okay. A lot of images, sharp. When it is done uploading, we'll now be able to annotate and then export it for training. In simple description. Does anyone have any question I want to ask while we're waiting for this?
So I know we are still waiting for the annotation, but I just imagine this earth related this thing in my head. If it is to be normal image, like normal objects, like everybody can easily identify that, oh, the annotation is correct and all that. But when it comes to like medical images, if one is not in that field, you might not actually be able to know if it is well annotated. So I want to know what can somebody introduce in that moment to make you know that it is well annotated for all these disease detection and all that.
You call the doctor. No, you won't go do work, doctor. You never say anything. You call a doctor. That's why in most medical projects, there must be a doctor in the team. For example, like Millions AI that we are trying to use food to help people with chronic condition. There's a doctor in the team that facilitates all those medical processes. All right. Is it done? Okay, so now you can auto label. You can label myself. You can label with him. This one you can invite people. You can outsource labelers. Wow, it's been on the added this thing. All right, so we want to label everything. This work go much. Yes. So wow, this is a lot. So we annotated like few of it, and then we see how it goes. Why didn't I find small image?
I don't know. I think you should be able to like select maybe like 10 instead of uploading all.
Mm-hmm. I'll just do a little. So now, what do I do? What's this one that I'm seeing? Is it not downloading? Okay, good. So it does 50 by 50. So now I'm going to first of all click on the image, click the particular place I want to annotate, this is the place I want to annotate. Right? Now once that annotation is done, I'm going to save and I should give it a label. So the model we want to use 1 minute. That's using air. It's in what you're saying. Okay, sorry. I was meant to click here. So you click there and then you come here, you annotate the place you want to annotate. It's annotated, we call it brain tumor. Right? That's the name of the, if we had like two labels, two things, I'll be like brain tumor 1, and also like brain tumor 2. So let's say I wanted to brain tumor 2. So I wanted like to annotate different objects in an image. But now we have only one object, right? We annotate that, saved, you move. You come back, that one's already done. The next image, I don't know if there's a brain tumor or not. I don't know if you want a brain tumor videos or not. Is a brain tumor itself. Move on. Is a brain tumor. Save. Move on. This Ellen, you were correct. We wasn't be on them. Okay. So it's still loading. The brain tumor here. Save it. I don't know if there's a brain tumor or not, but let's just do it. We'll keep on annotating like that until move to the image to trend, move the image to valid. Then later we'll split it. I don't know if there's a brain tumor here or not. There's a brain, right? Please. Yeah. Okay. I don't know if there's brain tumor here or not too. Anyways, so yes. Once we're done training, once we are done doing it, we now can come back here. We can back to this place here. You click here, you go back, and then you see that we've already annotated 15 images. So we'll add these 15 images to the data set. So you click here. Right now we have 0 data sets. So we click data set. So now in this place, we want to split image between trend and so remember to so translation trends so let's say we have an image of we have 100 images, in our case 15. So we want to train an AI model to detect an image of a brain tumor. We wanted that when we are training this model, the model should do very, very well. So one of the things that we do is that we split the data set into 3 different parts: train set, validation set, and test set. It's going to be our train, it's going to be our V, it's going to be our test. So what happened is, let's say this is 70, 30, so 70, 20, 10. When this model is training, it will be comparing itself against the validation and using that to adjust itself. And that's what we spoke. We did last week class, right? In the class we had I'm sorry, I think last year when we did TensorFlow, and then this test data set we use it to test our model later on. All right, but some people can just use only train and test. People do it sometimes if they don't have a lot of data sets. So, but for us, since I want to teach you guys, I'll split it by trend, valid, and test. So, how many percent do we want? I want the trend to be, let's say, like 70%. The test should be like 10% of the image. This one should be like 20%, like that. I'll add the 15 of them to the data set. So now you've just fine-tuned Roboflow instant model. Relax. All right. So now when this is done, we have gotten our what? Our data set here. Something went wrong. This might be issue with the model. I didn't ask you to train it. No. So we've gotten our data set here. So now we can come here and export the data set right here. So I'll come here, my data sets, and here's my data set, 15 of them. I can customize overflow instance, upgrade weight. I want to download it. You guys have done like some changes on this your side. Yeah, I think it's somewhere on here. Or versions. All right. So now, when I come to versions, I want to get my data set out. So there's no augmentation applied yet. Now remember I told you guys about augmentation. Augmentation is when we want to add some to the images so we can extract more images, flipping the image right, left, any I want to do it. Right? So yeah, I want to download the data set. What I'll do is like I come here, I come to download, and I can see the download to zip. My format is gonna be what? My format will be in yellow V26. Then I'll download the zip. So what is this for? Yeah, you are over your plan storage limit. Oh, I think I finished my limit. Wait to I have some projects. Let me delete them. Anyways, but when you come here, you'll be able to do what? To download the images.
I think you can use this thing that you showed last week, the code instead. Won't it work?
I don't want to use. I wanted to download it, Sha. But I think you can also use code. So if you come here, show download code. Format is what? Format is yellow 26. You do this, you'll be able to download the code. But as of now, I can't download code. I can't download the code because I've finished my data plan. So
Okay.
yeah, but that's exactly what I wanted to show to you guys this week. Does anyone have any question? So with this, I think you guys can go and customize your data set yourself and try to build something.
Apart from the fact that you actually downloaded that data set, I think you shared one video that man was actually taking pictures around, like it was literally snapping with his phone all around. I think sweet or something. Yeah, because this particular data set now, we just went on Cargo and downloaded. And I feel like some of this data on Cargo say they might have been annotated on Roboflow. So, but for any data that is personal to you, like maybe I just discovered I want to do something on something around me. So I have to like take pictures of those things around. Now, what is the disadvantage in doing that thing? Because I know sometimes maybe camera is not capturing the picture very well. It might be like I don't know. What's the challenge around that thing? Or that's the normal way to collect data sets too?
So the thing is like it depends on, like for example, when I'm trying to like oh my god. I'm trying to like see if I can empty the things I have so I can export these things. So the thing is like it depends on what you're trying to do. So what you can do, and there are most of times, for example, in this project I'm working on that lens, bro. It is so hard to find data sets because like
Mm,
people are not doing things in the agricultural space. So no one
mm.
cares. So now what do? We pick cameras by ourselves and we go hunting. We go hunting for data sets. Once you hunt for data sets, but you need to snap it in a very, very good way. So you need to make sure you pick the data set, you snap it in a very, very proper way. Once you finish snapping, then you now use that data set and use it to do your model training. You feel me? So you need to make sure you do your own job very well. Because even the data set you're seeing on cargo, someone suffered to take that data set to arrange it. That's why in the AI industry right now, companies selling data set are making a lot of money.
Mm.
Because data set is AI food. The way you eat food, that's what AI eats. That's why you're seeing issues around GPT, Claude, all these things. Some
Mm.
of them failing because of data set. They literally to train them, and now there's shortage of being some practices done to be able to get these models to do very well. Whatever data set you see on the internet, those images one by one before you could download it. Computer vision and AI, data set pre-processing and data set arrangement is always one of the most obvious and most important tasks. Once you get that done properly, the only thing you'll be doing going forward from there is just to arrange, like to come to the thing and arrange images. Like you just come, you arrange the image, you pre-process, then you use the right model, the right upper parameter, and you are good. If upper parameter does wrong, you tweak the model a little bit. But without having good data sets, you'll just be doing trash. Imagine the data set you're having is blurring images. The images are blurring, and then you are expecting the model to be able to predict an image of a cow, image of a dog, image of something. It shouldn't work. AI is not magic. AI is like garbage in, garbage out. All these things you are saying, GPT, Claude, everywhere, up and down. Garbage in, garbage out. If they use wrong data set to train these things, they wouldn't get any good result. You feel me? So that's just the thing, Sha. Lastly, everybody go collect. And you have to make sure you do your own work very well. You get your data set and then you train. Let me check if I can get this thing again. Do you understand what I said though?
Yes, I understand. But then what's like the benchmark for the data sets to collect? Like, what is
Bro,
like the
1 million
amount of
images.
data you should collect?
1 million.
1 million is that possible to get?
Just computer
Hey, you are breaking. I don't know if it's from my end.
database.
Hey, another people hear him. I can't hear him again.
I can't hear him too.
Yeah, you are breaking.
Model
Network is terrible.
that was released, they used 1 million images to train it. I don't know if that it was done by a woman. It was released to be trained. It was images, it's just the beginning. Um, where's what I'm looking for? Wait. By data sets, then download. Where did I say download? Okay, in versions. Now in this, I'm going to create a new version. Can you guys see my screen?
Yes.
Can you see my screen?
Yes.
Okay, so I'm going to let me delete the version I had like some many months back. All right. So I'm going to create a new version. It's already done it for me. Now what my version? I'll be like brain tumor. That's my version name. Now, I'll now add pre-processing. This is going to be done automatically for me. Watch, we have 15 images. 15 images total. Training set 11, test set 3, training this one, training set test set 1, validation set 3. Once I add pre-processing, watch what's going to happen now. I want to add some pre-processing step on the image. First of all, there are a lot of things you can do. You can add grayscale. So this is going to pick some images and apply grayscale to them. But already our image is on grayscale. We're not going to do that. The next thing we can do is to crop. Our image is already cropped. Resize. Yeah, we want to resize a little bit because maybe they are too big. So we say we want to resize to it's already okay, Sha. Let's not resize it. What else? Modify, adjust contrast. Yes. Now the reason we are applying these things is because, like, you may get a brainstorm image that is not doing very, very well. So you want to create a lot of image data set that even when bad images are being given to you, the thing can be able to, predict very well. Do you understand what I'm saying? That's where
Yeah.
augmentation comes, and that's what we are trying to do right now. We're trying to add in some steps, something so that this model can be able to detect a bad image if we have one in future. So right now we've added a pre-processing step. We're going to add hologram equalization for that's our contrast in our images. This can be done with OpenCV though, but they do it automatically for us. Augmentation. Augmentation is like we want to do a lot of things like flipping the image left, right. So in case we have a brain tumor image that is facing down, facing left, right, the AI do work and still detect it very well. So I'll add an augmentation step. You can rotate, you can add grayscale, add saturation, brightness, motion, blur, a lot of things to it. So I want to add this. I want to add this. So if my image is looking like this, it will flip the image by 2 times, clockwise and anti-clockwise, and also upside down. So I'm going to generate 3 images out of only one image now. So if I click this, I've added that. I want to add share. So share, like, twist the image a little bit. Done. So you see the image is now little thing. That's why it's good to use this Roboflow for. But they have limitation. I think you can only do it for Zach. Just add some crazy things though. And then this one called saturation. You're trying to add like some saturation, so you can adjust here to add saturation to your image. We're trying to add blur, so in case we have an image that is not doing so well, that is blurring, our AI model can still detect very, very well. And then we're also adding hue, hue, right? So I'm going to increase the hue value, and then we add something like flip. So this flip, what it does is like it flip the image upside down. You see, it flip the image vertical and horizontal. So you see, we have generated like 2 images from one. So if you see, out of 15 images, we flip 15, we're going to generate 30, is it 45 images in one? Because it will be one, or like 30 images just with one image. We that was going to be 15 times these two. You see, so if we look at our last image, what we're going to get at the end of the day, we must have generated up to, we say continue. So minimum size, we can use this, then do version notes, and then horizontal, vertical, clockwise, counterclockwise, where we've added some augmentation steps, and then we have generated a total of how many images? It's still coming. We'll see it once it's done. We generated 37 images out of 15. You see, so now my image data set has increased from 15 to 37 after doing some augmentation. So you see. So Now with this, you can now export it anywhere you want, maybe as a zip or as a code, and then use it to train your model. So that is just one. That's all right. So let's say I want to download now. We've added augmentation, and I can now go ahead to download image. So I want to download as zip to computer. Continue format is going to be in YOLO 26. And then the other things are the same, like what I shared to you for training. So this is what I wanted to show to you guys today. All right. So you see our files. When we are training next week, I'll explain to you guys what these files mean. But I think you almost already been seeing it in the code you used already last week. So if you open here, you see that this is your trend, this is your test. If you open here, you see images. These are the images, right? And then these are your images, and then these are like your labels. So these labels show like this image where there is the tumor. So your labels, these are coordinates 0, 0.5, 0.56. So this particular label, this particular one, the Roboflow generated 3 images in one. These are the labels for all the 3 images. One is the first label, this is the second label, right? I guess so. Oh, wait, this is 0, 0, 0. Okay. Oh, this is the label. The label is 0, 0, 0. That's brain tumor. And this is the. But let me open this and I see what I'm doing well. This is 1, 2. Oh yeah. This is 0. This right here, you saw right here, is the label. That's what, if we had 2 data set, 2 types of data set, 2 images in it, it will tell us something like the first one is, let's say if this was brain tumor, the second one will be like, let's say it was a cat, it would be like 0, 1. So this is our label. So this is the label here. So we can map this to either a cat or a dog. It can be mapped to either whatever thing, maybe house or something. But YOLO already does it automatically. And then this is the bounding box. This is your X1, Y1, X2, X2, Y2. I'll explain everything on Friday once we come back. So we've spent more than 1 hour. But I think you guys should understand everything I just explained. All right.
Sorry, the
Any
images
question
that you
before
opened
I
the
go?
other time. Okay, can you hear me? The images that you opened, it looks like they are merged together.
Yes, that's what I just saw. It's like, only if there's a new thing they did, like
Okay.
they meshed the images. I don't know why they are doing this though. Like they meshed images recently. This one is one. Like they just pick the thing, merge it, and flip it or something. Remember, I did like 4 different things. Anyways, so I think like with that, you guys can be able to go and pick something and do with it, right? Wait, was I share my screen?
Yes.
How did you guys see my screen?
Yes, we were seeing your screen, but now it's off.
All right. Who is this Abila? I've never seen you before. Who will be? All right, we're good, Sha. There's no one talk.